All right, so multiplication of whole numbers. So the main things we have to talk about here is what is multiplication? Models for multiplication. Oops. Some number properties. We've talked about these before, like commutative and associative. And then eventually we'll get into mental calculations, but we also have algorithms. Oops. And the book puts models and algorithms together. I kind of separate them out. And then we've got mental calculations and approximations. We're not going to get through all of this today, but we'll get through most of it. And then next class on Monday, we'll review some of this stuff and hit the things we didn't get to cover very much. So first thing is, what is multiplication anyway? So if you could just take a moment to write down on a piece of paper what multiplication means to you. What does it mean to multiply? Like I could give an example, 2 times 3 is 6. Okay, but why? Why is 2 times 3 6? Question mark. 2 times 3 equals 6. Oops. Why should that be the case? What does multiplication mean that brings me to that conclusion? So write down what you think about what multiplication means. And then we'll investigate further. So an example, a situation, a little bit of explanation. So if I were to ask a younger person about this, I might say, well, what is 2 times 3? And they would say, oh, well, that's 6. And I'd say, okay, well, why is it 6? And they would probably respond, well, because 2 times 3 is 6. And I would say, okay, well, what does times mean? And they would say, well, it means multiply. And I'd say, what does multiply mean? And they'd say, well, it means times. Uh-oh, times and multiply mean the same thing, but what do they both mean? So if you could share with me, either in the chat or by voice, what you think multiply means, I would greatly appreciate it. Okay, I got chats already. To find the total of how many groups, repeated addition, numbers per group. Oh, those are great answers, nice. Okay, let me write these down. And if you have another idea out there in the audience, please share. So far we've got repeated addition. Also numbers per group. Both good. To find the total of many groups. Okay, total of many groups. Okay. Anybody else want to add something to that? So I'm going to try to use those ideas to demonstrate why 2 times 3 is 6. Why isn't it 5? Why isn't it 7? Why isn't it 3? Why has it got to be 6? Okay, so let's see. let's call this method number 1 there. And I got to decide if numbers per group means the same thing as total of many groups. Those may mean the same. Let's try to figure that out. Okay, so for method 1, 2 times 3, I guess would mean 2 3s added. So 2 times 3 really means 3 plus 3, and I know how to add. That's definitely 6. Okay, I like that. Repeated addition. Numbers per group. Numbers per group. Okay, so let's see. Numbers per group. Would that be like there's 2 groups of 3? So here's a group of 3. And here's another group of 3. Altogether, that's 6. Okay. And then total of many groups. So the total of many groups, I'm thinking that might be the same thing here. Does that seem reasonable? The 2 people who wrote to me?
Yes.
Yeah, okay. So 2 groups of 3 is 2 times 3 or 6. Okay, cool. And then maybe just like a juxtaposition there, 3 times 2 would be 3 groups of 2, which looks a little bit different because I have a group of 2 and another group of 2 and another group of 2, but I still get 6 out of it. It just is a different way of getting there. Okay, I like that. Cool. So we've just created 2 models for multiplication. Nice, as rock. Models for multiplication. So model number 1 is typically repeated addition. If you look at addition in a dictionary saying, hey, what does multiplication mean? The standard definition is repeated addition. So repeated addition. Oops. And sometimes the definition gets a little algebraic, which is kind of sad, but true. So the definition in a book might say something like n times m means that you have n groups of m. So you have a whole bunch of m's added up. How many of them you have? You have n of these. And so that's the definition, the standard one. It's also a model because we can get physical and show it. All right, related to that is slightly more physical. It's the groups of model. Sometimes it's called the set model. Groups of model, also known as set model for multiplication. And a more concrete example would be, say, the 4 times 3. The multiplication symbol literally means groups of. So I can replace the symbol with the phrase groups of 3, and I can build that. So here's a group of 3. Here's another group of 3. That's 1, 2. Another group of 3, the third one, and then the 4th group of 3, and then we can count them up and get a total of 12. So why is 4 times 3 12? Well, because multiplication means groups of. That's why. Okay. Another model, and one of my favorites, is the area model. And it's related to probably one I could say is a 4th model called the array model. And the area model is multiplication is an area, meaning length times width. So in the area model, I would draw a region that has a length and width of 4 and 3. I usually like to do base and height because sometimes length and width confuse me. So that's an alternative approach here, base by height. So usually I'll take the first number and draw that horizontally as my base, 1, 2, 3, 4. So there's my 4, and then I go up from there, 1, 2, 3. So that'll be my 3 high. So then this rectangle right here is 12 when I draw those divisions in for each unit. So I have 3 units that way, and I have 4 units this way. And then I can count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and there's my 12. Okay. So area, length times width. The array model is very similar. The array model is just a rectangular configuration. And the array model, they don't have to be connected. So I would just have a grid that is 4 by 3. And so it might be something like a grid of X's or a grid of dots. So I would have a row of 4 and another row of 4 things and yet another row of 4 things. So this would be my array model for 4 by 3 equals 12. So an area is connected. It's a thing I could paint. An array is a grid of unconnected things. So it could be like seats in a classroom, for example. The book, in the very beginning, when they talk about the definition of multiplication and they mention the repeated addition, they offer a 5th model. Sometimes this is called the tree model. Sometimes it's called a Cartesian product. The book calls it a tree model. And it's more related to choices. So maybe we're talking about cars. And a car has some choices. You could choose from the color, like maybe you could have a red car, or a blue car, or a green car, or a white car, which I think is like the most popular color in the world for cars right now. And then some other options for a car, let's see what some other options would be, like interior. So that's the outside color. And then we might have choices for interior. And so maybe the interior, it could be some kind of dark interior, could be a light interior, or a leather interior. So if I have 4 choices for color by 3 choices for interior, how many choices are there altogether? And we can make a tree for that. So if we do color first, we can choose to have a red car, oops, it's supposed to be an R, or we could have a blue car, or we could have a green car, or we could have a white car. Now, if I pick the red car is either going to have a dark, a light, or a leather interior. Let's see, I shouldn't have done light and leather. Oh well, let's call that one LE for leather. And the blue car, well, that could also be dark, light, or leather. And the green car could also be dark, light, or leather. And a white car could be dark, could be light, and it could be leather. And so at the end here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 choices total. And that model is known as the tree model or the Cartesian product model. And these models are all related. They're just different physical ways that multiplication comes up in our reality when we're doing stuff. And that's the idea of a model. It's to make the operation physical. Why is 4 times 3 12? Why isn't it some other number? Why does it have to be 12? Each of these models demonstrates why it has to be 12, because this is what we call multiplication. And again, those are physical models for what multiplication means, how we get the answers that we do. My favorites are either the area or array. Typically, I like the area one. So we're going to take a little closer look at the area model and base 10 blocks is what we're going to do next. And this is where we're going to jump into breakout rooms. So I'm going to explain what we're going to do. I'm going to get the link and put it in the chat. It's also on the website. So let's see. Home at the bottom of module 2 is a link to another Math Learning Center thing. And so here I'm using the area model with base 10 blocks. And the question that your group's going to try and answer is, what multiplication equation is modeled here? And we'll break it down and try it with some other examples. So I'm also going to put this link in the chat in case you don't have that page in front of you. I'll also add this to the video for those who are, oops, I didn't go in there. There we go. So for those of you who are looking at this in the future, hello, future for math friends. All right, next, groups. So again, your goal, once I get the groups going, is to consider this image here. This image here represents a product, a multiplication problem. Multiplication problems means two numbers were multiplied and the result is the answer. That's called the product, okay? So multiplication is a factor times a factor equals a product. What are the factors here? What's the product here? Please explain with your group. And it's group time.